Hello everyone, my name is Mehmet Ismail. Today I will explain how to make loops in IRM32 assembly and how to complete task which was given by my teacher. First of all, about the task, compute the sum of all integers from m to n, starting from integer m stopping n, using register 0 and register 1 respectively. Then we need to use register second as sum of these numbers and use R3 for storing bytes per word value, then use R4 for storing the computed offset and R5 for computed actual address to branch 2. First of all, let's look how this code must look like in the C language. So as you can see, firstly we make first variable, second variable as first and second number, then third variable as summation, and after that we have our loop. So let's divide loops by steps to understand what we need to write in IRM32 assembly. Int I0 I wrote just to fill this empty space. M less or equal to n. So in this situation, we first of all we need to compare m and n, and only after that, after comparing, what we need to do. We need to finish this command. We need to add to summation the summation itself plus the m number. And after that, we need to move. The next step is to add m number 1. Increase m by number 1. And after that, we need to come back to for loop. Then we again need to compare. If this statement is true, we need to do this command. And after that, we need to add 1 to m. And etc. etc. And till m will be more than n. So first of all, as I said, we need to have first 3 integers. It will be, it's my code in assembly. First of all, R0, R1, and R2. R0 is equal to 1, just for example. Register 0 and 0 is register 1. I just wrote like that just for example. Register 2 must be 0, like initially must be 0. Then as it was said, use R3 for storing bytes per word value. Word value in assembly, in IRM32 assembly is 32 bytes or 32 bits or 4 bytes. So that's why I equal this number to 4 bytes. Then what I did, we need R4 as computed offset. So that's why I gave with ADR means address, so I give the address of the label to this number. So address of finished I gave to R4, address of loop I gave to R5, and then I found the difference between finished and loop lines. Why I did this? To compute the distance between for and finish lines. So the next, as I found, it will be our computed offset. Why I chose R4 finish and R5 loop? Because later I wanted, because teacher said like program counter R5 must move program counter to the beginning of the loop. So that's why I wanted R5 register be initially addressed to the loop, to the beginning of the loop. So after that, as I said in our C code, we need to compare firstly, secondly do the command, thirdly add 1 to m number, and do this in loop. So first of all, as I said, I compared R0 and R1. Then I wrote this: add less or equal to. If R0 and R1 less or equal to each other, so then to summation, I add the summation itself, and R0, it's like our first variable, as you can see. Then again, add less or equal to, we add to register 0, register 0 itself, and number 1. Oh, no, we had to register 0, number 1, and say this in register 0. Then what is this doing? Why I wrote add greater than, because if compare says that R0 is greater than R1, we need somehow to stop the loop. So these two lines will be skipped, and then our program counter goes to add greater than equal to, and we add to R5 register 4. Register 4 is the distance between loop and finish. So R5 will have the address of finish line. So by that method, our loop will be finished. And then without less or equal to, greater than, without all these conditions, I just move program counter to R5, because no matter what happens, if this line will not be executed, program counter goes to the beginning of the loop. If this line will be executed, it means this two will not be executed, and program counter goes next to the finish line. Why I made this? Again, as I said, we need commands which are in the loop, and we need commands which are stops the loop or skipping the loop. So and also why I added less or equal to, and there I added greater than, because when R0 after several addings 1 to its own number will be equal to 5. Like first there it will be equal to 5, then it not be executed, it goes to the beginning of the loop, compare says that it's 5 and 5, it will add 5 to the summation, then only after that it will be equal to the 6, and after it's equal to the 6 it goes back to the beginning, it compares, as we see 6 is more than 1, because like we need to add 5 itself. So that's why I added less or equal to, because I wanted to add 5 itself to the summation. And if R0 will be 6, R1 will be 5, this will not be executed, this will not be executed, this will be executed, and it, as I already said, make register be equal to, make register 5 equal to address of finish line, then we move to the finish line. So now let's step by step try to execute in our minds my code which I wrote, and then let's also take a look how it looks like on computer in the CPU later. So R0 equal 1, R1 equal 5, R2 equal 0, this like, and then R4 is equal to the distance between loop and finish. So compare R0 and R1. R0 is less than R1, so that's why R2 equal to R2 plus R0, it's equal to 1. R0 equal R0 plus 1, so R0 now equal to 2. It will not be executed. Move from counter to R5, like the beginning of the loop. Again, compare 2 and 5. 2 is less than 5, so we add 1 to 2, it's equal to 3. Then R0 plus 1 is equal to 3, not executed. Move from counter to beginning of the loop. Now it's 3 and 5. Again, they are not equal to each other. We add 3 plus 3 equal to 6. R2 is equal to 6. There is R0 equal to 4, not execute to the beginning of the loop. Then 4 and 5, again, they are not equal to each other. 6 plus 4 is equal to 10, R2 equal to 10. 4 plus 1 equal to 5, R0 equal to 5, not executed to the beginning. Compare, they are equal to each other, 5 and 5. Again, it works, that's why 10 plus 5 equal to 15, R0 equal to 1, R0 plus 1 equal to 6, it not executed, move from ground to the beginning, 6 and 5. Now R0 is 6, R1 is 5, so that's why R0 is greater than R1, not executed. R5 equal to R5 plus R4, so we move program R5 address from beginning of the loop to the beginning of the finish line, then move program counter to R5 to the beginning of finish line. There we have SVC2. It's supervisor command 2. It means that like supervisor command number 2 stops the execution of everything. So by that method we added 1, 2, 3, 4, 5 to each other and we got 15. So it works. Now I will show if it works on computer or not. So let's take a look at our code, like it's a code which I already showed you. Let's compile and see what will happen. So firstly, R0 gets the value 1, R2 gets the value 5, R2 initially 0, R3 gets the value 4, then R4 gets the value 30. It's address of finish, as you can see. R4 finished, R4 gets the value finished. Then R5 gets the loop, the value loop, and then R4 change. Now it's 14. It is the difference between finish and loop. Let's go next to our loop. So we compile, and there we can see that it's negative because R0 is less than R1. So like we subtract from 0 R1 and we get the negative number. Then we can see that we add to R2 the value 1, it gets the 1. Then as you can see, it also executes, so R1 gets the value 2. This is not executed, so nothing changes with R5. And now it moves from counter to R5. R5 has the value 1C. 1C is this line, it is the beginning of the loop. So step over, and as you can see, after this line we go back to compare. So that's how it works. From counter goes back to the beginning of the loop, of the address of the loop label. Then we do this several times. As you can see, R0 is 5 right now. After compare, we can see 0. So it is so R0 and R5 are equal to each other in NZCV flags. So finally we add to R2 R0, like the 5. Then This again, this is not executed because R0 is no more than R1. Again, now we can see that R0, R2 will not change because this will not be executed. No change. Again, no change. Now this line will be executed. As you can see, R5 changed its value from 1C to 30. And as you can see, the beginning of finish label, the address of the finish label is 30. And right now, when I will tap step over one more time, it goes to SVC and our code is finished. So what we get in the end, we get that R0 is equal to 6. That's when our code stop. R1 never changes. R2 is F, but F in from this system is equal to 15. So our code works. R3 is 4, R4 is 14, like it is no change. R5 was 1C, now it is 30, and program counter is 30, like it is in the end of our code.